Hello everybody, here comes a review of Elasticity of Demand Part 2. And first thing we looked at was how elasticity behaves at a standard linear demand curve. So for any linear demand curve, if you pick the midpoint right in the middle of such a demand curve, and then elasticity at this point will be exactly equal to 1. So that's the point of unit elasticity. The lower half of the demand curve is the area of inelastic demand. So here elasticity is smaller than 1. And this is what we call inelastic demand. The upper half of any linear demand curve is the area of elastic demand. So at any point here, elasticity is larger than 1. And therefore, we call it the area of elastic demand. Alright, so, well, we can look at a formula to kind of illustrate it, but for the sake of making this review shorter, I'll skip that part. Next thing is to look at two extreme cases. So what if you actually take a standard linear demand curve and tilt it until it becomes either perfectly vertical or absolutely horizontal? Well, if a demand curve is perfectly vertical, then this is what we call perfectly inelastic demand. Because at any point on such a curve, elasticity equals 0. Right, and it makes demand at every point inelastic. The opposite case, if you tilt your curve in the opposite direction until it becomes flat, and that's the case of perfectly elastic demand. And in the first case, I think it's pretty straightforward, right? As you're changing price, or as price changes, goes up or down, well, we're moving along this curve, but up and down, but quantity doesn't change at all. So clearly there is no response to changes in prices from quantities. So that's why this first case we're dealing with perfectly inelastic demand. And in the second case, basically this price becomes like a trigger price. If price goes just a tiny bit higher than it is here, then the quantity demanded completely shuts down and becomes 0. And actually that's curve describes what's going on for any price taker. So if you are part of perfectly competitive market and you are taking market price the way it is and you're selling something that everyone else is selling, right? Then you basically can only sell stuff at the given price, the generally accepted market price. So if you charge anything more, any higher price, then people will not buy from you, right? And this is the case of perfectly elastic demand. All right, next thing on our list is to look at the relationship between total revenue and price and see how this relationship is affected by elasticity. So to do so, we're going to draw two graphs. One is going to show a demand curve. 1, 2, 3, 4, 5, I guess 6. And another graph is going to show a relationship between total revenue and the price. So price, quantity, price, total revenue. Total revenue is basically dollar sales. So it's P times Q. And let's start with the diagram on the left. And see how total revenue will be changing as we increasing price. So let's say price was 0. What will be total revenue? Well, total revenue will be 0, right? Quantity sold will be that large, right? But as price is 0, 0 times whatever Q you have is 0. Then let's say we raise price to P1. And by the way, we actually can plot total revenue for this price right away here. So at price 0, total revenue is 0. As you raise the price to P1, what happens? Well, your sales go down, so people getting less because now you start charging. But total revenue increases, right? Because you're getting some money. And you actually can see your total revenue on this diagram by looking at this rectangle, because P times Q is the same as the area of this rectangle. So it's total revenue 1. And we actually can plot whatever number we get for total revenue 1 on the diagram to the right. So let's say this is our total revenue at price 1. If you increase price even higher, then again you will sell actually less than before, but your total revenue will still be increasing. Actually, you can probably see it on this diagram. So this rectangle looks larger than the previous one. And so if you plot number for total revenue that you can figure out from here, you will get, so this is P2. And that should be maybe somewhere here. All right, and so this is how you can actually build this diagram on the right, on the right graph. And basically, if you do this step by step, you will end up having a curve that looks like this. All right, well, looks good enough. So it's looking at this graph, you can figure out that you get the largest total revenue at the price that actually matches the midpoint on the demand curve. So P3 gives us the largest possible total revenue, which will be this number, total revenue 3. And if you keep pushing price even higher, well, then in fact you will start decreasing your total revenue. So at P4, your total revenue will drop down to here. At P5, it will drop down to, and this is actually P4, right? And this is P5 to here, and at P6, well, your total revenue will drop back to 0. All right, and this is how things are going to behave for every linear demand curve, for any linear demand curve. Now, so what do we see on this diagram, especially here? We can see that total revenue might follow price, or actually it can go against it. So when price is low, then increases in price result in increase in total revenue, right? As you go from P1 to P2, actually total revenue is increasing, right? Because you go from TR1 to TR2, and TR2 is clearly larger. But if you're increasing price from P4 to P5, then your total revenue actually drops, right? And in fact, P5 gives us the same total revenue as P1, but simply put, we will go back, right? So, and you can see it on this upper half of this total revenue curve, and actually it makes sense because upper half of this curve is backward slope, so it actually has a negative slope, which indicates the negative inverse relationship between price and total revenue. And finally, we can actually notice that, well, this upper half of the demand curve, which matches upper half of total revenue curve, is where demand is elastic. So elasticity is larger than 1 here. And the lower half of our total revenue curve, which matches lower half of total revenue curve, is where elasticity is smaller than 1. So in other words, demand is inelastic. So we can make the following conclusion. We can conclude that if demand is elastic, then as price goes up, total revenue actually goes down. And if demand is inelastic, then as price goes up, total revenue goes up as well. So generally speaking, if demand is inelastic, then price and total revenue move in the same direction. So total revenue follows price. But if demand is elastic, then total revenue goes in the opposite direction compared to where price goes. And we actually can kind of flip this observation and come up with the total revenue rule, which says that, well, if you notice that as price goes up, total revenue goes up as well, well, you conclude that we are dealing with the inelastic demand. If you notice that as price goes up, total revenue goes down, then you can conclude that we're dealing with elastic demand. And if it happens that as price goes up or down and total revenue doesn't change, well, we can conclude that we are about this point where elasticity is 1, so demand is unit elastic. All right, as simple as that. Finally, let's see how we can apply this model or this story to the case where we have changes in market price due to changes in market equilibrium. So let's say this is our demand curve, and let's draw a total revenue curve next to it. So 1, 2, 3, 4, 5. So that's the midpoint, so that will be the maximum total revenue. Okay, good enough. So total revenue, price, quantity, price. Now, let's imagine that we have a given supply curve, and that well, brings us to a certain equilibrium. And so the original supply curve looks like this, and then let's say we have an increase in supply. So increase in supply means a rightward shift in the supply curve. Hopefully you remember that. So what does it do to equilibrium price? Well, equilibrium price goes down, right? And if this is the case, and noticing that we actually happen to be at the upper half of our demand curve when elasticity is larger than 1, so demand is elastic, we can conclude that as price goes down, total revenue in fact goes up. How can we know that? Well, we can just trace change in price on this right hand diagram and see how it's going to affect total revenue. So at P0, total revenue was total revenue 0, and at price 1, P1 here, total revenue is here. So clearly a decrease in price, or actually increase in supply that causes a decrease in price, results in an increase in total revenue. Okay. Interestingly enough, if we had an increase in supply starting from a different equilibrium, basically starting from an equilibrium at the lower half of our demand curve, where demand is inelastic, then an increase in supply will result again a decrease in price, but that decrease in price, as we know, would cause a decrease in total revenue. So let's again call them P0, P1. So, and if we trace the effect of a change in price, in this case, we'll see that actually total revenue goes from this amount to this amount. So total revenue again 0. Well, seems like it might be a little bit confusing, but I hope you guys understand what's going on here. I can maybe change colors so we don't confuse those total revenues. So total revenue 0 red, and total revenue 1 red, or red total revenue 1 and red total revenue 0. So in fact, in this case, total revenue is going down. So basically, yeah, an increase in supply, which causes decrease in price, might increase demand, total revenue, or decrease it depending on which section of our total of our demand curve we are. So if we happen to be at the area of elastic demand, right, then an increase in supply, decrease in price will result in an increase in total revenue. But if we happen to be at the lower half of our demand curve, where demand is inelastic, then the same thing, increase in supply, which causes decrease in price, will result in a decrease in total revenue. So that's how we can apply that model we just learned at the previous slide. Alright, so that completes our review of this section now. So thank you for your time, and I'll see you later. Well, actually, I will talk to you later.